welcome to VJD Academy. This is Anil Kumar, Faculty of Digital Electronics. Sir, in the last lecture, we have learned about the basics of sequential circuits, which are flip-flops, counters and registers. Now, I would like to teach the basic difference between flip-flop and latch. Both are sequential circuits, of course, and both are very important circuits. We are going to learn all those things in the further classes. But now I would like to teach a few differences between flip-flop and latch. Just make a heading: differences between flip-flop and latch. Sir, here flip-flop and latch, both are basically sequential circuits. I would like to write the differences for these two. The first one I would like to take here, latch. L-A-T-C-H, latch. It is also a digital circuit. And second, other side, I would like to take flip-flop. Flip-flop. Sir, the first difference I would like to mention here, latch is a level triggered. Latch is a level triggered circuit. And coming to flip-flop, it is a edge trigger circuit. Edge triggered circuit. And the second point, what is level triggering? Suppose if you are applying input signal, like here you are just applying input signal is like this. This is a input signal, and now this is having a pulse width like this, TPW, propagation time, or we can say pulse width of this particular signal. And now this is what input signal, input we can say. And for this particular input, the moment when we are using a latch circuit, what is the output response? Sir, here if you see, within this particular input pulse duration, the output may be varies many a times. That is what the output of latch. Here if you see, this is what input, and then the output for this particular input signal may be varies multiple times, on and off, on and off, on and off. Likewise, for this particular given input, output may be varies many a times. That is the output of latch. And coming to here flip-flop, here the output may be varies whenever the input we are applying. It is having basically two types of edges. One is positive edge and another one is negative edge. Sir, what is the positive edge? If you see, this is the rising edge and also we can say positive edge. And the negative edge, this is a falling edge or also we can say negative edge. Whenever we are applying a edge trigger, positive edge trigger like this, then only the input may be accepted by the flip-flop inputs. And now here also, the moment when we apply this kind of input, then the moment when it is coming, or the moment when we are applying this kind of falling edge, then the input may be accepted by the flip-flop to operate the corresponding operation. That is what positive edge and then negative edge. Coming to the third part, or we can say third point, the circuit diagram of latch. If you see, sir, latch circuit can be developed by using NAND gate or also we can say NOR gates. Even any kind of flip-flop we can develop by using with the help of NAND gates and also NOR gates. That is the reason we are calling NAND and NOR gates are universal gates. In the previous lecture also, in the previous classes also, we are able to implement, we could able to implement many circuits with the help of NAND gates and NOR gates. We can implement any kind of circuit with the help of NAND and NOR gates as like multiplexer. So throughout digital electronics, we have seen three types of universal circuits, or we can say two types of universal gates, NAND and NOR, and one universal circuit that is called multiplexer. So that is the beauty of digital electronics. And now coming to the third one, latch can be designed with the help of, we can say, NAND gate or NOR gates. Sir, the circuit diagram of NAND gate. This is what the circuit diagram of NAND gate. Let me take two types of NAND gates here. And now the output, we can say this is Y. And now exactly this is Y bar. And now the output of Y will be connected to the input of next NAND gate. And now the output of this Y bar will be connected to the input of the first NAND gate. We can say that these are the two inputs A, B. And now this complete circuit can be calling as a latch circuit. And what is the flip-flop? Third one, if you see, sir, here also I would like to implement one NAND gate, and here also I would like to implement another NAND gate here. Yes, this is what Y, and then this is Y bar. Exactly, both are opposite outputs always. And now this output will be connected here, and now this output will be connected over here. This is the same implementation as like a latch. But what is the basic difference between latch and flip-flop? If you're really asking me, sir, there is one steering circuit. We can say that there is one control circuit. There is one gate circuit. We are just placing before the latch to get the command over output of the flip-flop. If you see here, for the particular input, this is the black color. If you see the input we have applied, and for this particular output for this particular input, output must change only once, but here output is changing many a times, because there is no command, there is no control over the circuit. To get that particular control over the circuit, we are just placing a gated circuit or steering circuit or gate circuit, control circuit before this latch. Let me try to implement here. You please try to observe. Here I would like to take one NAND gate, and also I would like to take one more NAND gate here. Yes, now here input A, and now this is input B. In between these two NAND gates, I would like to take one clock pulse, and for this clock, here we are applying both NAND gates. This is the circuit diagram of flip-flop. Sir, if you really asking me, this particular part we can say gate circuit or control circuit or we can also call as sometimes steering circuit we can call as. And now the entire part, this is simply we can say latch circuit. The combination of latch circuit, the combination of gate circuit, combinedly we are calling as flip-flop. That is the third point. And now coming to the fourth point, here there is no command over output. Fourth point, if you see, no command over output. Output may be, that is output varies many times. And now here the fourth point is command over output, and output varies only once. Output varies only once with respect to, we can say, applied given input signal, either positive edge or negative edge triggering. And these are the basic differences, sir. And now we will start to learn types of latches and the operation of latch, and also we will try to understand the basic disadvantages of latch and how to overcome these disadvantages with the help of flip-flop we are going to see. Thanks for watching. Please do subscribe.